Hello everyone, today we'll be discussing another Leetcode question which is related to TP, and this one is very standard and a easy question. So what we have to do is I'll take the example from the question itself: 10, 9, 2, 5, 3, 7, 1, 0, 1, and 18. So we have to give the length of the longest increasing subsequence. That means that all the numbers in that subsequence must be increasing. So it's like in the example itself, because we can see that the answer is 2, 3, 7, 10. So we can see all the numbers are increasing. The next number is greater than the previous one. 2, 3, 7, 1, 1. So this is the longest one we can find in the given list. We can also find few others, like there is 2, 3, 7, 18, and 2, 5, 7, 101. So that's how we have to do it. Or 2, 5, 7, 18, which I think I already covered. So yeah, that's how it is. And simply what we have to do here is it's a pretty easy straightforward one. I'll just quickly give you the recursive approach for this. So 2, 9, 10, 9, 2, 5, 3, 7, 2, 5, 3, 7, and 101, 18, 101, 18. So just like other questions related to subsequence and substring, this also requires us to um, choose amongst the options of what we can do with a number. So for example, if we are at, let's say, a number 5, so there are two options. One is to um, like, let's say we are forming a subsequence from starting, so we have to add 1 to that. We pick 5, and if it is increasing in that subsequence, then we add 1 plus 1 in the length of the subsequence which we are calculating. So this is one option, choosing 5. And the other option is, um, and we have to also check, yeah, there are two things we have to do. We have to check whether 5 is greater than the last element which we saw. Okay, so if it is greater than the last element we saw, then we have two options. The options are either to pick 5 and or either not to pick 5. So these are the first two options. And if 5 is smaller than the last element, okay, so this will not count because 5 is already smaller than the last element, so it is not ever increasing. Okay, so that's why we'll say that 5, since it is smaller than the last element, we have only one option, that is to not pick 5. Okay, and I also would like to explain why when 5 is greater, then also we are not picking uh, picking 5. Like, we are choosing amongst two, either to pick or not to pick. You might argue that if 5 is always increasing, or it is increasing than the last element, then we should always pick 5, right? But this is not the case. The reason is, like, let's say we want to form, there are two things, there are two subsequence here. One is 2, 5, 7, 101. The other is 2, 3, 7, 101. Okay, so we can see, if we would have picked 5 necessarily, okay, every time if 5 is greater than 2, we are picking 5, then in that case, we couldn't have picked 3, because though 3 is increasing is greater than 2, but 3 is not greater than 5. Okay, so that is why we have to choose amongst two. Okay, we have to choose, even if 5 is increasing, then increasing compared to 2, even in that case we have to once choose it, and we have to also not choose it. Okay, so both of the things we have to take, because we have to consider that there can be element. So for example, we are considering 5 and last, right? So there can be elements which is greater than last, but it is smaller than 5. Okay, it is, there is an element which is greater than okay, signs are different. There can be element which is smaller than last, but it is less than 5. Okay, so if we choose 5 every time just based on the fact that 5 is greater than last, then element that is meeting this condition might be ignored. Similarly, if we choose in every condition, like after choosing 2 we see that 5 is increasing, it is greater than 2, we choose 5 every time. So in this condition, what will happen? The element 3 will be ignored. Okay, so we have to, in the recursive stack, we have to have a function call which is having 2 and having 5. We also need to have a function call which is having 2 but still not having 5. Okay, so that we are in this stack also goes into the depth and finds a call where it can pick three. So that is the reason that even if the current number is greater than the last number, still we choose amongst two options, that is either to take this number up or to not take this number up. So this is the main thing which we have to remember. So the logic is simple. The logic is like, if we have a function solve, in this function we are having variables like temp. Temp is the temporary variable which I have taken to calculate the length of the substring or subsequence, and the other variable is I. Basically, this is looping to the next element, and there is one more element, that is last. So last basically signifies, okay, which particular element we saw before last. Okay, I'll leave some space for the break condition, then I'll just simply write, if nums of I is greater than last, we choose amongst two options. One is solve, and we take the current element. So if we take the current element, temp will increase, I will definitely increase because we are going to the next element, and we'll also have last, as since we are taking the current element, we'll have it as nums of I. And in the other condition, we'll have solve will not increase temp, because it's like not choosing 5. Here we are not choosing 5, here we are choosing 5 after seeing 2. Okay, so last what was 2 here. So here we have temp will not increase because we are not choosing 5, but still we are going to the next element, so I will increase, and the last will remain last. Okay, so since we are going to the element after 5 and we are not choosing 5, that's why last will remain 2. So these are the two options if nums of I is greater than last. Else, if it is not greater than last, else for this, if it is not greater than last, then we have only one option, that is not to choose 5. So if we don't want to choose 5, the temp will not increase, it will remain temp. I will increase because we are going to the next element, and uh, last will remain last. So this is one solution. And one break condition would be simply if we are reaching, first I'll write to capture the answer. So if temp is getting greater than answer, the current answer variable, then we are simply putting temp in answer. Okay, and the break condition would be simple, like if I reaches I equals to length of nums, that is it reaches the end last element, then we simply return that. So we can put that condition over here. So you see that's the recursive solution I wrote initially. So if temp is greater than answer, then answer we're putting temp in answer. If I reaches the last element, like beyond the last element, we simply return. If nums of I is greater than last, then we choose amongst the two options. Else we choose amongst the one option. This is very straightforward, simple question if we are going for the recursive approach. But since this is not a question related to recursion, we have to come up with with a dynamic programming or DP related solution. So that also I'm going to discuss. So that is also very simple again. So simply I will write up the example which we have the question itself. 10 9 2 5 3 7 537 101 and 18, I guess. Yeah, it is. Yeah, so simple. First of all the element in itself is at least one element in the increasing subsequence. So for example, let's say we say take two. So just two is at least one element which is the great is the like strictly increasing subsequence. So similarly we'll have a answer list or final list or whatever you want to say this, have it there. We have all the elements initialized by 1 2 3 4 5 6 7 8. It's 8, right? 8, yeah. So we have to initialize the list by 8 ones. That is saying that all the elements are increasing subsequence in itself. After that, what we have to do is, if we reach 5, again, I don't know why 5 is caught every time, but if we reach 5, Okay, so what we have to do is we have to start from the start and see key whether this element is greater than 5 or not, or less than 5 or not. So 10 is less than 5, no, so there is no option. 9 is less than 5, no, so there is no option. 2 is less than 5, yes, so we have to compare that the current value is 1. 2 was less than 5, so we'll add 1 to it, because this is basically the first element in the increasing subsequence, and this will prove out to be the second element. So we have got one option, 1 plus 1. So amongst 1 and 1 plus 1, what is greater? 1 plus 1 is greater, so this will be updated to 2. Now we reach 3. Okay, so we see 1 1 1. 10 is greater than 3, no. 9 is greater than 3, no. 2 oh sorry, 10 is greater than 3, 9 is greater than 3. Is 2 greater than 3? No. So since 2 is not greater than 3, so for 3 also we got one option, that was 1 plus 1. Because what was it, 2? 1, we added 1 to it. So we have one option, 1 plus 1. So again, amongst 1 and 1 plus 1, what is greater? 2. So we update this to 2. Then we come to 7. Now this is going to be interesting. Is 10 greater than 7? Yes. So we are not going to do anything. 9 greater than 7? Yes. So we're not going to do anything. 2 greater than 7? No. So what was the value at 2? 1. So first option for 7 is 1 plus 1. 5 greater than 7? No. So the second option will become, now since the value at 5 is 2, that means the longest the subsequence, strictly increasing subsequence which we saw till 5, has the length 2. So we have to add, since we are seeing 7 now, we have to add 1 to this particular 2. So the second option is 2 plus 1. Okay, so then 3, is 3 increasing, 3 greater than 7? No. So again 3 has 2, so the other option is also 2 plus 1. So among these three, what is the greatest? 2 plus 1, that is 3 is greatest. Similarly, if we go to 101, we'll come comparing from here. 10 is smaller than 101, then first option will be 2. 9 is the same, then 2. 2 is the same, then the option is 2 again. 5 is the same, 5 is smaller than 101, so the number at 5 is 2. 2 plus 1 is 3, so the next option is 3. And then we come to 3 again, the option, there is an option 3. Then we come to 7. Now 7, the subsequence up till 7, the longest in strictly increasing subsequence up till 7 is 3. Since 7 is smaller than 101, that's why in this 3 we are adding plus 1, and the option becomes 4. So basically these are the options amongst which we have to choose the greatest one. That's what we are doing every time. From the start, for the particular element, we are comparing it with elements from the starting of the list, and we are seeing that if the element is smaller, that means 101 can act as the next big element. Okay, if that is the case, whatever is the value for that particular element, we are adding 1 to it. So that's what we are doing here. So this becomes 4. Amongst these, the greatest number is 4. So why यहाँ पे भी value will be 4. Then 18, again I'll directly write the answer. It has several options from which we'll have to add. We'll take 4. So, and then for every iteration we also check, okay, whether answer element can be updated because the length of the longest increasing subsequence is increased. If it is the case, we are updating the answer. So that's such a short solution, it's very easy. So you can see I have just initialized the list with 1, 8 of, like, let's say for this example, 8 ones, and then I've run a nested loop where I runs till the length of the nums and j runs till the I. That is like saying key for particular 5 we are running j from here to here. So that's what I've done. If nums of I is greater than nums of j, then we are simply simply updating li I from either the previous value of li I or the lij plus 1, whichever is greater, we are updating li with that. After j loop is end, every time we are checking whether the current value of I or the current subsequence which we got is greater than the answer which we are having. If it is the case, answer, if I scroll up, you can see answer is something which is initialized to 0, the same variable I use for recursive approach. And if it is the case, update answer, return answer, and we are done. Submissions. I have to see how many of these solutions I beat. 26.35%, but yeah, this is buggy. This keeps changing. Next time I scan, I'm pretty sure it will change. So yeah, there's a solution that's very straightforward solution, and that's like beautiful to understand it, beautiful to understand the logic. I hope you understood it. I'm pretty sure you will understand it if you rewatch it. So make sure to rewatch, like, subscribe, and all the things that you do to other YouTube channels. Thanks a lot.